Okay, guys, it's 11. Well, it's 10 o'clock here in Switzerland. We're going to kick this meeting off. A couple of notes. The format for this meeting is that everyone can join and listen in as viewers. And it's only me, Marco, and Mervyn who are presenting and talking in this meeting. I hope that through this presentation, you find everything insightful and interesting. So I just want to spend 1 minute briefly thanking everyone for their time and for joining this call. I just want to mention that as far as the history of this project has gone, it really has been, 2023, I think, was the low point for me personally in this project. And we had to get through some very tough times and difficult decisions. And 2024, for the most part, was an equally frustrating year. Just in terms of we've had to work, we're very, very thankful for our funders who stuck with us and the people in our project that stuck with us. It has been a very hard journey, but I have some good news as we get ready for Christmas, that 2025 is going to be a very, very fantastic year for the AIBlock project. And I thought it would be worth giving the stakeholders a first peek at what we have lined up for 2025 and where the company direction is headed. So that's really the context for this meeting. Part of it will be a presentation, and part of it will be live demos. I must also say ahead of time it is live demos, so when things take a long time or they break, then you know it's real. And that it's not canned. So with that said, I'm going to start sharing my screen and presenting, and we'll take it from there. And Marco, if I cut out at any point or if my audio goes bad or something, just please let me know.
Will do.
Thank you so much. Okay, well, actually, I'm going to share my entire screen. It's better that way. Okay. Fantastic. Okay. So the first thing to share with all our stakeholders is the AIBlock company position. So I'd very much appreciate it that when you talk with your friends and colleagues, this is a very, very good way to introduce how AIBlock is fundamentally different to other layer one technologies and where we fit into the larger picture. So Bitcoin, very much in 2008 going on to 2009, introduced the world to the idea of smart cash. And I know that we all know it doesn't currently behave like cash in a traditional setting, but that was certainly the intent of their social experiment. Ethereum came along and introduced smart contracts. And we are now introducing the concept of a smart market. And I'm hoping by the end of this demo and presentation that we have sufficiently explained what smart markets are and how they're different to what's out there currently. A recording of this will be made available. We'll edit it and release it probably on YouTube. So we'll distribute the link for anyone who wants to rewatch this content at some future date or share it with your friends. And then, you know, there's opportunity to also see these slides and go through the presentation at your leisure. Very, very importantly, smart markets are autonomous, and we'll demonstrate what we mean by that. And they're really designed to optimize value, not necessarily price. For the producer and the consumer within a market. And the solution space to this is realizing in how to effectively combine machine learning with blockchain so that we can optimize economic and social outcomes. At this point, what is the one thing that we need to know? What is the one thing we need to take away from this discussion, and how best shall we understand smart markets? And I'd really like to start by explaining the sigma function. So if we look at this is the Ethereum white paper as it stands today. And what you'll notice is that the entire Ethereum white paper, now it's the reason I'm using Ethereum as a benchmark here is they're a couple of $100 billion ecosystem and platform. And what is the thing in the white paper that they try to get across to the viewer? What is the message they're trying to relay? And they're trying to relay the concept of a state transition function, and this is known more broadly as the sigma function. How you go from one state to another state. And this seems like a very peculiar and almost random thing to go on about. And not only do they show the sigma function for Bitcoin, and we'll get back to what this is, and by the end of this discussion, it'll be very, very clear through the demonstrations of exactly what a sigma function is. So I don't want anyone thinking this is going to be very academic. It's not. It's going to be very practical. But not only do they do a review on Bitcoin state function, sigma function, but they also go and show that what they're going to do differently is they're going to introduce the Ethereum sigma function. And this is really their uniqueness. This is really their selling point. So a sigma function is a fancy way of saying that systems go from an initial state in increments to a new state. So they go from state 1 to state 2 to state 3, and so on and so forth. And the thing that takes us from one state to the next state is the sigma function. And this is a very, very, very important idea because we're talking in blockchain about processes. How do you do finance, cash flows? How do you do payments? How do you do contracts? And you do it by transitioning from one state to another to another. And it sounds oversimplistic, but this is really when you want to stack up different chains and you really want to understand the differences between things. It doesn't really matter that you understand public key cryptography. It doesn't matter that you worry too much about consensus mechanisms. You don't really need to understand too much about anything. The rules for how you go from an initial state to a better state, that encapsulates a notion of everything that you're about. It's kind of the canary in the coal mines. It's the litmus test. It's the one thing you really want to understand. So all you need to know is the sigma function. Okay. Now let's put this into a practical thought experiment. I want you guys to imagine that simply by drinking coffee that comes from a smart market and by paying for that coffee with smart money, magically, for reasons that we will come to understand during the course of this presentation, there's a reduction in child labor practices. The entire system becomes more sustainable. And you know what? The coffee even starts to taste better. Now, this is the big audacious dream. This is the thing that should make everyone listening to this call going, but that's impossible. How can this be? And that's why it's such a good anchor point to frame the narrative around. Because if I'm telling you that the simple act of drinking coffee can improve coffee and can improve the social, not only the economics of coffee, but the social environment in which coffee exists, you can't turn around to me and say, oh, this is what Ethereum does. It's not what Ethereum does. And you can't say to me, oh, this is what Tether is all about. It's not what Tether is all about. And the reason is that's not their sigma function. Ethereum is only interested in making contract changes. Tether is only interested in making payment changes. What we are saying is that by combining the power of AI with the power of blockchain, you can start to change a market. So this is the market sigma function. And this is a very revolutionary idea. And it's important just to say that, again, we're not talking about incrementally evolving to something slightly better, but we're talking about introducing a revolutionary approach to these problems. Marco, just to check in, how am I doing? Is everything kind of happening at a reasonable pace?
Yep, we're doing good.
Cool. So like Ethereum in their white paper had a diagram for this is their sigma function, this is our diagram. And we're going to do at least 2 demonstrations of the sigma function in process. Like we're gonna do it step by step by step by step. We're going to show it all on the back end. And at the end of it, this will be very, very intuitive and natural. So here's a bunch of people in the green block. These are primarily producers and consumers. And they make decisions. The consumer is making a decision on what he wants to, or he or she wants to buy. And the producer is making a decision about what he or she chooses to make. And that results in a bunch of transaction data. Now, the deep insight is that and we're going to show an actual worked example of this, and it will become very, very crystal clear at that point. All you need is the transaction data. From the transaction data, you can use AI to make inference, and that inference will give you a market insight. You can also use the transaction data to extract the logic, and the market insights applied to the logic will give us a market action. So we're going to go from an initial state, Q0. We're going to go through this entire process. The market action will update the market into Q1, and it will go round and round as a loop. And the reason for this is it's self-optimizing. Every single time the market readjusts its state, it's in a better state than it was previously. And so there's constant fitting, and everything is happening autonomously without human interaction. And so what we get is so rather than just having a decentralized network, what we get is a decentralized intelligent network. Now, showing the sigma function in this way and how you can change a market state incrementally, it doesn't seem very, very complicated. And so one of the big questions is, why are we uniquely positioned in the market to be able to execute this insight? And one of the really important ideas is that we uniquely have the architecture. If you wanted to automate gaining market insights, you're going to have to use a GPU running some sort of AI or ML model to get that market insight. If you want to take market action, if you want to process a transaction or process cash flow, you're going to need a GPU. And what you also want to do is you want to incentivize this GPU network that it behaves correctly. And so what we're talking about is the need to take AI or ML models, integrate them with blockchain infrastructure, and integrate this with mining. And if you look at this very unique combination, you'll notice very quickly, for example, Ethereum doesn't do mining. You'll also notice that Tether doesn't do ML integration, and they don't have the network and the right infrastructure to be able to run these 3 functions together. So now that's enough about the kind of the theory and the high level discussion. It's time to kind of get under the hood and start looking at the tool chain that we are building up and have built and unpack it. At this point, for everyone following along, if you wanted to, you could go to the various websites and links as they pop up in the demonstration, and you can follow along in real time. So you will be able to see things reacting as I do it on the internet, because this is now part of the live demo. So if you do have another tab open and you want to type in these URLs, I'll give us all kind of 30 seconds to do so if you want to. And you can see that this isn't a click through, that as it is on my computer, so it is over the network. Okay. So the first thing, Marco, can you all see the Block Explorer as I've called it up?
Yep, I can see it.
Yeah, perfect. Marco, how many? This is a thought experiment. Now I'm being a little bit cheeky. How many people RSVP'd that yes, they would attend our call?
About 14.
About 14. Okay,
yep.
So let's take that number 14. So what I'm going to do is I'm going to run a lottery now. And I want to pick randomly one of the 14 viewers to give 100 AIB coin to, and I'll transfer it in the wallet to them as an actual thing. So what we're going to do is we're going to take note of the current block. We're currently on block something, something, something. The last three numbers on 907. So we'll use 908 as a reference block because it hasn't been published yet. I'm going to dive into 907 and we're going to look at some of the data structure. And I'm going to show how I can use block 908 to randomly select a winner for a competition or something like that. Okay, so we can now go into a block on the Block Explorer. Actually, so this is a good time actually maybe just to do that 30-second pause I was talking about. Anyone following along, you guys can go to Explorer. Can you see this on the screen, Marco, this top screen belt here?
I can see it. Yes, I can see it.
Okay, so it's just HTTPS, but you don't have to type that part in. It's explorer.aiblock.ch. So anyone can just kind of click on that, and it will take you to the same website that I'm working off of, so we can kind of follow along. Okay. So while you guys are potentially going to explorer.aiblock.ch, I'm going to go back to the block. We're currently on block 910. So let's set it to 911 as the one that we actually use, because now everyone's kind of joined. They can see for themselves the current block height is 910. Okay. So if we look at the block structure, what you're going to notice is the block height. This is the number of blocks that have been processed since we started the AIBlock main chain. And this is a very, very important number. If you're a trader and you understand option contracts very well, you'll have an expiration date that's embedded into the option, after which you cannot exercise that options contract anymore. And when you want to now think about, you're trying to create a smart market around options or derivatives, and you need to somehow get the smart market to sense the progression of time. This is surprisingly a very hard thing to do. Bitcoin, there's no way that you can program time into a Bitcoin instruction in a reliable way. And in Ethereum, it's a little bit better because they kind of record timestamps, but you're relying on the honesty of the miner to correctly record the timestamp. Uniquely with AIBlock, our blocks are exactly produced every 30 seconds. It's a deterministic function. Our blockchain is unique in that regard. And so I can tell you that one real day in calendar time is exactly 2,880 blocks in AIBlock. And so by using block height, our smart markets are deterministically aware of time, and we have a very, very strong and important internal clock. Now, that might not seem like a very, very big deal, but we use this to enforce things like strict transaction ordering. We use it to think about the progression of time. But the other value that's in a block is a secure source of randomness. So if you look at this entry over here, you'll see something called a unicorn seed. This is unlike other sources of randomness in blockchains in that it meets security levels. So if we remember the challenge that I said, Marco, is we're going to go to block 911. I can go to the witness seed, and I can take the last number of the unicorn seed, which is 4. And by doing that, I can say the winner of 100 AIB coin is the 4th person who RSVP'd to the link. And there's no way I could manipulate this. There's no way I could pre-compute it. And this introduces the first very important concept of a smart market. There are no people in the smart market. There's just a consumer buying coffee, and there's just a producer making coffee. But everything else, from the logistics to the decision on new product lines to the pricing, all of these market functions can be strictly encoded at a machine level and left to run autonomously. So if you needed to have a competition for a user where you say lucky number viewer, the 100th, or of the 100 people that logged in, this person wins. But this is more important than just doing promotions. This gives you a secure baseline for all cryptographic functions. And that's something I'm not going to go into too much, but this is why the block structure is very, very, very important. It comes with a built-in deterministic sense of time, and it comes with a built-in sense of secure randomness for any signature you're going to perform, for any selection that you have to do arbitrarily. So this is a very, very important concept. That gives us a sense of how the blocks are structured. And now what we're going to do is we're going to look at a particular transaction on AIBlock. So we can just sort of go into this transaction over here. And we'll just wait for it to load. It's obviously a transaction with a lot of inputs, so it's busy looping through all of the inputs and outputs and aggregating them. So it's got 17 inputs over here. So the way that you view a record, and the reason I'm doing all of this is when we start to go through the smart market sigma function, where we're going to make coffee taste better just by drinking it, we're going to be using the block explorer to investigate certain records. And so it's very important that we take everyone through understanding how the records are structured. Okay, so I can see that this transaction is for a token, so it's for a payment, it's not for data. If it was green and labeled item, I would know a piece of data has moved over the blockchain. And so for a lot of our smart market functions, I'm going to be pulling in a lot of items into the calculations that we do. And here are the inputs. So this is what it looks like. This is the logic. So that determines how payments are made. I'm so used to looking at this now, I don't even see op, dupe, op hash. This is just a payment coming in. These are 17 individual input payments. And it results in an outgoing balance of, we can look here, this combined address has 1,118 AIB coin associated with this address. Okay, so that's how you look at this. You can see the number of blocks that we can see the block height that indicates the time. We can see the number of transactions processed. We can see the circulating supply. We can look at block data and we can look at transaction data. So that should be very intuitive after this explanation. And it's really fun to kind of keep track of what's going on. This gives you an indication of, a sort of how much business we're doing, if I can put it that way. Okay, so that was a discussion on time and randomness. Now we can look at data. So this is now a sneak peek of the next generation of the AIBlock wallet. So this is the developer version of Seeker. It hasn't been pushed as the main version yet. So everyone on this call who's using the Seeker wallet will have gone to se3ker.com, Seeker, but with a 3 before the K. And they would be familiar with the ability to send an AIB coin or receive an AIB coin. This dev branch of Seeker.com, you won't be able to follow along there because it's for developers only, but you can go to Seeker.com, register a wallet. You can send us your addresses. That's your hub for all things AIBlock. So over here, if we go down to tokens, what you're going to see is that we support, if we look at overview, the new version of the wallet is a multi-currency wallet. So we can support AIB coin on mainnet. We can support AIB coin on testnet. We can support Ethereum, and we can support USDT. So this is Tether. These are the 4 currencies that are natively supported now by the latest version of Seeker. What you'll also be able to do is a swap. So you will be able to pick anything based on the Ethereum chain. So we could go to Sol, and we could pay in dollars or whatever it is, and we could swap Solana for dollars or whatever it is, and then keep it on Ethereum. So here's the new swap functionality. If you want to send somebody a token, you can now choose to send them a token or an NFT. I have an NFT collection, which I'll take you through now, that I've made. And I use the NFT collection for my smart market function, where we'll unpack all of that. And if you want to receive something, you can pick what it is that you want to receive. So you want to receive AIB coin, and it will generate a QR code for you to send. to the person sending you AIB coin, or alternatively, you can just copy the address and send it in a message or an email. So that's kind of all the, and then over here is just your history tab where you can see actions on. We have a nice feature where you can download all of your transaction history into a CSV file. This is important practically if you're going to be filing your tax or making declarations or running an asset register. And then there's some backup functionality here. So that's the high level of the Seeker wallet. It's got different schemes. This is my kind of custom scheme, but it doesn't really matter. Now we're going to go into the NFT section. So this is my NFT collection over here. I've got something called Cosmic Latte as an NFT. I've got something called Calculate Price. I've got a coffee prompt, and I've got some options data all saved as NFTs. And this is my NFT collection. So these are states that are going to go into the Sigma function for a smart market. But you could just make a fun NFT and sell it as art. And I'll kind of take you through what that looks like. So what you'll do is you will click Mint an NFT. You'll choose if you want to mint it on mainnet or testnet. You can just sort of drag and drop any kind of image that you want on it. So there's a random image. You can give it a title. You can write a description, fun art, and that's really it. You can now preview your NFT, and I'm not going to create it. It'll write an entry to our blockchain. And in all of time and perpetuity, everyone's going to wonder who made cookies and what does it mean. And it's just sort of wasting the ledger space unnecessarily. But you would click create NFT now, and it would push it straight to main chain. So using this tool, I have minted these NFTs yesterday. And so with that in mind, we can kind of, so having reviewed, that's how we can add data in a no-code environment on-chain. So as a kind of way to get ourselves familiar with the big demo at the end, we've seen that we can intrinsically handle concepts of time and randomness. We can add data through NFTs, and we can manage things on our Seeker wallet. And now we can jump into the market action concept. So the first problem I want to give the smart market. Now, I'll do this first as a demo, and we are going to be demonstrating everything today using ChatGPT as the AI client. And I'll speak at the end about our actual choice of clients. You can use absolutely any clients that you want. We have a special client called Morgan. This is a dry run presentation that will be redone in January 21st to the larger market. But we really wanted to give the stakeholders a first view at what we're doing and where we're going. So if you want to see an integrated Morgan client, please join us on January 21st. So here's the two things. I have some coffee data, and I have a coffee prompt. I'm going to very quickly go back through this. So I've got some transaction data, and I have a prompt. What I'm going to do is I'm going to use it to generate market insights. This will be applied to the logic to make a recommendation for market action. This is the Sigma function of how we take coffee from Q0, its initial state, to coffee in Q1 in its final state. Okay, so let's go and look at the Cosmic Latte data. Okay, so what do we have here? We've got an item that was minted yesterday. It's got a bunch of opcodes that are the logic on how it was created, and it's got an output, which is the fun part. Okay, so in the output, if you guys are following along, what's really kind of cool to do is you can take this URL. You can just copy that URL section and you paste it into your browser for any item, and it will pull the item across the network onto your local machine, and you can have a look at what this is in terms of an image. It has a description, if you remember how we were minting the NFTs, but over here in the description is the data field that we've, okay, let me actually capture the whole thing. Just give me a second. Okay. Now, to kind of prove to you that we're not that we're doing this for real, this is what the description was that was on chain. It encodes a bunch of binary. I'm doing this for the benefit of stepping you through what the machine sees on the back end. And this binary encodes something very special. It's a string of data. So if you look at the string of data, it seems to be data pairs. And if we kind of zoom in on it, you'll see that the pair is separated by a semicolon, and there seems to be an XY pair over here. So this is the data that we're going to be using. And if we open up our coffee data, you'll notice that these are the pairs. It's 0,561, 0,645. And when we go back to our decoded data, 561, 645, this is the string of data, which is this data object. And what this is this is a bunch of copy data representing the flavor profile versus the strength of the coffee roast. And because everyone on this call won't think in terms of strings and coordinates, I thought it would be much easier just to graph this data for you guys. So again, this is the Excel data, and you can see the clustering of it here. So it looks like that in the coffee data, what seems to be happening is there's a bunch of people that like a mild roast with a kind of a fruity flavor profile, and there's a bunch of people that seem to like a dark roast with a very strong flavor profile. That seems to be the preference data. And this data is nothing more than the transactions that have happened on chain. These are different purchases for different kinds of coffee, which create the transaction data. Okay, so hopefully so far this all kind of makes sense. Okay, I know there was maybe a lot of showing random numbers, but when we go back now, so we've got a bunch of coffee data. We've got 64 coffee sales that encode the metadata for the flavor profile and the strength of the coffee. I'm doing this in 2 dimensions because it's easier to follow along, but in reality, you would be optimizing a coffee market against the origin of the bean, the price, labor practices that are involved, flavor. There would be sustainability. It would be a very high dimensional set of data. So that's the data that exists on chain just from the natural action of the market buying the data. And here comes the powerful idea. So this part I'm going to go much more slowly through. And Marco, if you haven't seen this demo, I want to use you as my interaction points.
Sure.
If the next part doesn't make sense, just stop me as we go. So let's see what this item is. This is the other NFT. So the first NFT was all the coffee data. The next NFT that we're going to look at is a prompt for our AI agent. So here's the prompt. It's very easy to read, and we're gonna kind of read it word for word. I just want to copy this prompt. There we go. Okay, now the reason for this prompt is what we're going to do is we're going to give the miners in our network an AI prompt. Our miners are running GPU clusters so they can process AI logic. And they're going to look at the transaction data using their blockchain mining clients, and they're going to combine the insight they gain with the transaction data to create a new market state. This is the Sigma function. Okay, so what I'm doing is I'm now taking this. So this is a blockchain prompt, and this is very important. This is my promise to everyone who drinks my coffee. So I say, I've instructed, I'm a coffee producer who's selling my coffee through a small coffee shop in Zurich. And I really want to put customer satisfaction first. And I'm using a smart market. So I don't decide the product line. I'm letting the smart market decide the product line for me using AI and blockchain. And to prove it, I've captured this prompt, and this is what the prompt says. It says, go to the data, and you'll find 64 entries. Each entry consists of a pair of points that measures flavor profile against the darkness of the coffee roast. Now, what I want the AI agent to do is I want it to analyze the data and find clusters for me. Like tell me what are the product lines that people are interested in, and then give me that data back so I can execute on it. Okay, so now we're going, does that make sense, Marco, to you?
Yeah, makes sense to me.
So I'm taking the mining client takes the blockchain prompt. The mining client takes the blockchain transaction data. And now what we do is we say to it, go on, do the state transition function, reevaluate this market and improve it for us. What is the 80-20 principle? What are the 2 coffee products I should be selling my market? And tell me what those products are. Now, importantly, this is autonomous. I didn't hire a marketing company. I didn't go out and do a focus impact study group. I'm not relying on bias. I'm not trying to cheat the customer. I'm not trying to fiddle with value optimization. All I do is I tell the world what I'm about through my prompts. And these prompts are readable in English. They're very communicable. And everyone can go with their, and here we go. Okay. So it's identified a bunch of cluster value that we can take out. It's doing a whole bunch of deep analysis here. It's showing me the code that I can use to plot this. This is the joy of AI, and we'll let it finish running out. And what it's done, it's found. So now we can kind of just. I'm just going to end. Hang on, let it just finish this thing. Okay, so if you look at this 3 cluster approach, it's saying, well, you can find 3 clusters in the data. There's one at about 8,9,32,6,9. So let's go look at the data. And we can see at 3,2, here is one cluster of data. At 8,9, there's another cluster of data. And at 6,7, there's another cluster of data. And so the AI agent has said, looking at it, I can see that you have 3 product lines that you should take back to your customer. And these are the 3 product lines. But very, very importantly, that wasn't something that any human did. This was being done independent of any manipulation by the group. It also says that you can have an alternative strategy where you're segmented into 4. So it's given me kind of 2 choices here. And so now what we can do is we can take, so let's go back and look at the Sigma function. In the initial 0 state, people went out and they bought 64 different kinds of coffee. That generated transaction data. We then used an AI agent running on our GPU miner to give us market insight. And the market insight is, hey guys, there's maybe 3 or 4 different kinds of products that represent all of that diverse data. Now, what we're going to do in January 21st is we're going to take it one step further. That same AI agent that we bring into the system will now construct an order on the blockchain to go out and buy 4 different types of coffee and send it on to the consumer. Now the consumer can go out and drink more coffee, and the more sales behind each coffee is a vote for more of that kind. And so it will now be in a Q1 state, and it will just continuously update and evolve and fit. Hopefully this is a demo, not a final product, but hopefully it demonstrates how this can be applied to something like creating a new product line. But markets aren't just about making product lines. Markets are often very much about calculating price. Okay, so here what I'm going to do is, and I'm using Black-Scholes in asterisk because I never told the AI agent I wanted to use Black-Scholes. I have a bunch of data that represents European option contracts. So let's go and get that data. It's stored as an NFT collection. That's the aggregate of all of that data. Again, here is the serialized code. So this should now be a much more familiar process doing it the second time around. We're going to give it the base 64. We're going to get some hexadecimal. This is just what the machine would do on the back end. We give it the hexadecimal. It spits out some options contract data. So what that blockchain entry was, it says there's a call option with its relevant data. Here's a put option with its relevant data. Cool. I want to buy option 1 and you want to sell option 1. But very, very importantly, we're not storing the price. Okay, so let's see what the prompt says. So the prompt that I thought was a good idea, hang on. Yeah, there we go. Okay. So the prompt that I think makes the most sense is using the attached data, find the best algorithm for calculating European option prices and calculate the options prices for the 5 contracts listed in the data. Okay. So again, we go back to our choice of AI clients. It will then ingest the options data. Now, although we're doing it using JSON objects today, on January 21st, we will be API calling it straight from the blockchain. Again, I've given it the prompt. Sorry, I'm just stuck here. And then I say analyze. Now, again, when you're calculating an options price, who knows if you're using the right function? Did you record the data to 3 decimal places, to 9 decimal places? There we go. So there you go. It's got the 5 contracts. It's got the 5 options prices. And let's see what it used. I'd be very interested to know. And here we see it automatically detected that Black-Scholes was the correct formula to use. It understood that Black-Scholes needs to ingest this data. And then it wrote the code, it ran the function, and it calculated the prices. And so this means, and now what I would do over the AIBlock infrastructure is I would go to the nearest valence node, and I would tell the valence node, here is 6.04 AIB coin. Please give me, please transfer to me the rights of option contract 1. So by now, I think it should be a lot more apparent the power of this particular Sigma function. So what we're saying is that uniquely because we are a GPU-based architecture, because the transaction data, the transaction handling, the market action, the market insight can all run on the same infrastructure. And we're one of 3 coins that still has a mining approach. We're one of maybe 8 coins that use GPU technology. In terms of this stack, we are 100% unique. And so what Ethereum was saying is that they could run logic in a very complete way using their state transition function or their Sigma function. We're saying we can run any market Sigma function, any market Sigma function using the same template. It never varies. This transition schema is universal for all market functions. What I've done is lazily, I've shown you how we can evolve new product lines. I've shown you how we can procedurally generate pricing on contracts. We don't store this data. It doesn't get computed. I don't have to audit whether the Ethereum Solidity contract was written in the right way because it's beyond human manipulation. You stipulate a prompt, and that prompt defines your intent. Does this make sense to you, Marco?
It does, yes.
I'm putting you on the spot there. You can say no, because then I know if I need to go back to stuff. So what are some of the market functions that can now be autonomously run without intermediaries? Logistics, supply chain management, AML, KYC, pricing of assets, trading of assets, market insights, product line developments. And all of this is being run by miners. It's not being run. So there is a need for banks to take responsibility. There's a need for lawyers to take responsibility. There is a need for the actual driver of the truck to take responsibility for the delivery of goods. But that's only by function. They don't have to be gatekeepers. They don't have to be control points. They don't have to be labor driven. Now, one of the very exciting things that we will discuss in the forthcoming months is wouldn't it be cool if there was a cryptocurrency that could intelligently maximize or optimize its own supply to create real value? So you'll see a lot of tokenomic models out there. One guy will have a fixed supply coin, the other guy will have a rebase supply coin. They are bringing their human intelligence in and saying that this is the best way to do things. What we can do is we can give the supply management of AIBlock or AIB coin to our miners. We don't have to get involved. We don't need a DAO. We don't need a group to get together and work out what should the inflation rate for the currency be. It's a market function, and we have a Sigma market function uniquely. And so we can automate all of these things away. So firstly, the Sigma function allows us to automate all of our financial and market requirements. And also anyone using the system gets that on top for whatever they're doing and running. This is an important comment, but it's a little bit maybe esoteric. Tim Froese is a biophysicist who once famously said the best way to encode a brick is the brick itself. Because you might think about trying to describe a brick and you say, well, a brick is a rectangle. And then you might say a brick is a rectangle that's orange. And then you might say a brick is a rectangle that's orange and has a mass and has a... It turns out the most compact representation of a brick is the brick. And in a market, what is the building block? What is the brick of markets? And it turns out to be transaction data. You don't need anything more than transaction data. You don't need to offer somebody a computed price, you don't need to run Black-Scholes, get the price, write the price to a blockchain. The price can be procedurally generated when needed from the transaction data. The most compact representation of everything in a market is purely the transaction data. So where other chains that store price, that store product line, that store liquidity, that store all of these things as values, they don't have an efficient and compact way to run their systems. And the other thing is you're constantly having to inspect code. Like you look at a bunch of code as a layperson and you say, I don't know what the intention or the operation of the smart contract is. And so by using transaction data only and generating everything else from a fixed sized AI agent, what I mean to say is that we have the most efficient storage representation, but also the most effective way to communicate amongst people. If I sent you one of these prompts and say, this is the coffee market I believe in, I promise this to you, the investor, and I've blockchained it. All market functions will not be done by my shadowy backend people that you have no access to. And if you want to track the state of how my market is evolving, just run the prompt through a Gen AI agent, and it will speak to you back in English. You can just say, how would you go about segmenting this product? And it says, well, you can pick 3 or 4. But we're communicating effectively in human language, and we're compactly representing everything in the most compact possible way. So with that all said, and an understanding of, hopefully a clearer understanding of Sigma functions for markets, which is unique. Bitcoin was about payments. Ethereum was about contracts. We're all about markets. Victor Hugo once famously said, nothing else in the world, not all the armies, is so powerful as an idea whose time has come. 2025 is a fantastic year. The U.S. market segment, the U.S. market sentiment is positive. with the increase in Bitcoin price, there's a renewed interest and vigor in cryptocurrencies. AI is top of a lot of investment portfolios mandates. Very, very, very importantly, we're not talking about AI sitting on top of our consensus mechanism. We're saying that the AI is under consensus. If one miner runs the wrong AI prompt and comes to the wrong market state, the other miners are all running their AI agents in parallel in this distributed intelligent network. And so that intelligence is being checked amongst all of the miners. And if one miner now becomes a bad actor who is not computing the prompt fairly and openly, that market recommendation does not get mined out. It does not become part of the chain. And so there is no need to do enforcement. There's no need to check whether the miners are doing what they're supposed to be doing. They check themselves. And they are incentivized because they are earning coin for doing so. And so being able to talk about smart markets in a time where markets are increasingly challenging for the globe, being able to talk about how AI under consensus can power this, how we can talk about sustainability, how we can talk about social impact, and profitability within one project. The time has come for this project. And what I wanted to say was, why now? And the answer to the why now is that it is only now with the practical and accessible artificial intelligence, the performance of networks, and the maturity of blockchain technologies that it's not only possible to talk about smart markets, but to build them as well. And so our plan for 2025 is live use cases. The very, very good news is that come January 7th, our Nuvlio use case in Brain Futures will be live. And we have very, very cleverly selected key verticals to integrate into. And we have a lot of adoption and signed contracts in these verticals. So when you're thinking about applying smart markets in the real world, where can we show real impact really quickly? We can show impact in the agricultural sector. Oh, sorry about that. Let's just go back. We can show impact in the energy sector. We can show impact in the healthcare sector. So these are the three sectors that we heavily focused on. And so of the 15 use cases that we've identified, they all cluster and support these three marketplaces: the healthcare marketplace, the energy, and the agricultural marketplace. And that vertical integration and those live use cases drive very strong buy side for the AIB coin. The reason for putting this flame emoji or this flame icon or graphic on the sheet is I feel very much like we are the phoenix rising out of the ashes. As I mentioned, 2023 was a very soul-crushing year. It was extremely difficult to make it through 2023, and 2024 was extremely hard. Market conditions weren't very favorable at all. It was very, very difficult to continue with the team. We had a lot of strained relationships. We were very fortunate to be able to cover our costs and get some funding to keep us moving forward. But what came out of it, the benefit of the phoenix rising out of the ashes, is that we have now done absolutely everything once. Until you've done something yourself, pretending to understand it, it's a different matter having lived through something than read about something. So we have now understood all of the markets and financial services that support crypto, and all the good and the bad. There's a lot of bad. We've understood how market makers really function, what they're really about. We've understood how listings are supposed to work. We've understood the importance of community and marketing. We've understood the application of the protocol to the real world. And so having survived the very heavy 2023 and 2024 periods, we are now ready to relaunch. And the expression that I want us to talk about is that AIB coin is not a gold-backed currency. It is not a labor-backed currency. It is an AI-backed currency. And we will be unpacking that messaging and explaining what that means more. For people that are interested, we are very focused on community growth. We have a special forum called the Fremen Forum. And this is where we're going to have more of our technical discussions with our core community and grow a lot of the very low-end technical stuff. But just to make you aware of it, we will also be pushing a lot more YouTube content and YouTube tutorials. We're going to be doing a lot of targeted events where we're going to be promoting our SDK. So if you're a developer that already has a platform or framework that you love, let's say you code in PHP or you code in Python or you code in Java, we will bring an SDK to you for smart markets. You don't have to come to us and learn our weird coding. And we're going to be doing a lot more meetups. In terms of protocol growth, by January 21st, we'll be able to show you ChatGPT isn't the correct AI agent to use. For one thing, it isn't open source. And what I mean by that is the weights aren't available for download. So it might be open source in terms of you can, through a limited sense, interact with it and send it prompts and it sends you the results. You can't peel away the code and look into all of its weights. And so we're very, very fortunate that one of our core developers that we're working with is bringing Morgan, and I'll discuss Morgan in the final slides to you guys, to our technology stack. It's a really, really fantastic improvement on Meta's llama weights, and I'll describe that a little bit more. The other big thing, the other three big features for the protocol for 2025 is the release of our compiler. And when we start doing things like automating options contracts and getting more into trading and finance, this will be an increasingly important component. There will be opcode releases and some software development kits for different pages. The tooling that we will be releasing, an app hub page. So for people that are interested about the Nuvlio use case, the app hub page will be a place for you to go read up about Nuvlio, click through to their website, see the code that we're pushing, rather than having to check in for meetups and for us to tell you what's happening. The app hub page will show you the ready state of our use cases and our tooling. We will be re-releasing the mining clients, the public mempools and storage nodes. So that's what you guys can look forward to in terms of releases and upcoming events and things for 2025. A quick note on Morgan. Morgan is based on the Llama 2 weights. That is Meta, formerly known as Facebook's natural language Gen AI alternative to ChatGPT. And working with our core contributor, Jamie Gilchrist, we've been able to make Morgan deterministic. What you'll notice on ChatGPT is if you give it the same prompt multiple times, it doesn't always give you the same returned result. And that obviously is a deal breaker for when multiple mining clients are running the same inference. They need to be able to get to exactly the same recommendation consistently all of the time. That's a precondition for making the Sigma function verifiable and auditable. The other benefit of Morgan is it has something called LoRa heads. Those are low resolution adapters. So typically the weights that an AI agent use are in the gigabyte range. Morgan's weights are about 68 gigabytes worth of data that allow it to make generative predictions and responses to prompts. What an adapter head allows you to do is you can fine-tune Morgan to behave like a doctor, or you can fine-tune Morgan to behave like an auditor, or you can fine-tune Morgan to work as a lawyer. And each of these heads allow Morgan to take on specific functions. The reason why they're low resolution is it doesn't take another 68 gigabytes for every specialization. That 68 gigabytes is Morgan's core. The adapter heads are about 50 megs a piece. And so currently Morgan has 15 LoRa heads that it can swap between in a hot state to be able to comment as a subject matter expert in different fields. And the third feature that makes Morgan ideal as the choice of ML agent to embed into our Sigma function is that it's schemaless. And so what this means is it's been trained to recognize data in different formats. Whether you're feeding it data as a string or as a table or as a JSON file, it can extract the data independently of the schema that's been chosen. And that makes it composable and adaptable. Thank you very much for attending this call. We're on the hour as promised. Please feel free to reach out to us over any of our channels, email us or call us if you'd like to discuss anything else that you saw in this talk. Please make yourself available on January 21st. We will be redoing this whole presentation, but in a more integrated and more streamlined fashion. This was the dry run. And I hope this was interesting for everyone in attendance. Thank you very much for your time.